What is time dilation near a black hole? Have you ever wondered how time behaves near a black hole? It turns out that time acts quite differently in these extreme environments. Time dilation near a black hole is a fascinating phenomenon where time passes more slowly the closer you get to the black hole compared to someone far away. This happens because black holes have incredibly strong gravitational fields that warp the fabric of space and time around them. Imagine a clock moving toward a black hole. From the viewpoint of someone watching from a safe distance, that clock appears to tick slower and slower as it approaches the black hole's event horizon. The event horizon is the boundary beyond which nothing can escape. At this point, time seems to almost stop completely, making the clock appear frozen in time. However, for someone falling into the black hole, their own clock would seem normal to them. They would not notice any change in the passage of time locally. This difference occurs because gravity affects the flow of time itself, not just the speed of clocks. This effect is a direct result of Albert Einstein's theory of general relativity. This theory describes gravity as the curvature of spacetime caused by mass. Black holes, being incredibly dense, create extreme curvature, leading to noticeable time dilation effects. Even on Earth, we experience slight time dilation due to our planet's gravity. This has been measured with precise clocks on airplanes and satellites. But near a black hole, the time dilation is much more dramatic. As matter falls toward a black hole, it experiences stretching and distortion due to intense gravity. This phenomenon is often described as spaghettification. From a distant observer's perspective, infalling matter appears to slow down and fade as it nears the event horizon, never quite crossing it visibly. In practical terms, if you were to send a signal from close to the event horizon, it would be increasingly delayed and redshifted. This means the signal would shift to longer wavelengths as seen by someone far away. This behavior has important implications for how we understand matter and light near black holes. It also raises questions about how information might be preserved or lost in these extreme environments. Time dilation near a black hole is a remarkable example of how gravity influences the very nature of time itself. The closer you are to a black hole's event horizon, the slower time passes compared to someone observing from a safe distance.